All right. So next off, we have the concept of finding slope or gradient of the graphs. So the title is how to find the gradient. So we need to understand what does gradient actually mean. And we will understand this using two ways, graphical method and then the gradient formula. Now, you might already remember the y2 minus y1 divided by x2 minus x1 formula. That is called the rise upon run formula. That is the gradient formula. But where does that formula even come from? Let us understand that by going into the basics of what exactly is gradient. So I'm going to start with the graphical method. Let's understand what are the steps to figure out the gradient of a graph, but at a particular point. So have a look. These are the axes, and I have shown a particular graph where we have labeled a point A. So we need to figure out the gradient of this blue graph at the point A. So the step number one, let's read. We need to draw the tangent at that point. So let's go. This red line is the tangent to this blue graph. That's step number one. Step number two is find the angle theta that the tangent makes with the x-axis. So the angle between the red line and the x-axis, this is theta. And step three, gradient is tan theta, which means gradient for the graph at the point A is nothing but tan of this angle, tan theta. Now, since we are dealing with tan, it is important for students to remember basic values of tan. So here are different angles given from 0, 30, 45, 60, and 90. So the value of tan theta is 0 when theta is 0. Tan 30 will be 1 upon root 3. Tan 45 will be 1. Tan 60 is root 3. And tan 90 is infinite or not defined. It is important for us to remember these basic values for tan. Now let us use this table to figure out the gradient. So here is the same graph, the blue graph which we had drawn earlier. Now in this case, let us consider this point, the origin point, as point A. So what will be the gradient at the point A? So remember the three steps. Step number one, we draw the tangent at that point. So the tangent in this case will look like this. Step number two, we have to find the angle theta, the angle which the tangent makes with the x-axis. In this case, the red tangent you can see is along the x-axis. So the angle theta will be 0 degrees. And step three is the gradient of the graph at this point will be tan of that angle. So tan 0 is 0. Hence, we can write gradient at A is tan 0, which is just 0. Now, let us try to figure out the gradient of the same graph, but at a different point. So let's consider the point B. Step number one, let's draw the tangent. Step number two, we figure out the angle theta. So this particular angle, the angle between the red line and the x-axis. Approximately, we can assume that this angle is 30 degrees. Hence, the gradient of the graph at the point B will be approximately tan 30, and tan 30 is 1 upon root 3. So this is the gradient at the point B. Now let us figure out the gradient at the point C. Same step. Step number one, draw the tangent and let's try to figure out this angle. This seems to be close to 45. Hence, the gradient of the graph at point C is approximately tan 45 and tan 45 is 1. Similarly, let's consider the point D at the rightmost extreme. Step 1, let's draw the tangent. Step number 2, the angle theta between the tangent and the x-axis. Here we can observe that this red tangent line is perpendicular to the x-axis, which means the angle theta is 90 degrees. Hence, the gradient of the graph at the point D is approximately tan 90, which is infinite or not defined. And this is the graphical way to figure out the gradient. Now we come to the gradient formula, the formula which we are already aware of, the rise upon run, y2 minus y1 divided by x2 minus x1. So here we go. We start with the same graph which we had drawn earlier, a U-looking graph, and a point A is labeled. So we need to figure out the gradient of the graph at the point A using the formula. How do we do that? Step number one, if you remember, was to draw the tangent at the point A. So let's go. This is the tangent. Step number two is the angle theta between the tangent and the x-axis. Let's say that angle is theta. Now, in order to find the gradient formula, we need 2 points which are lying on this tangent. So let's say we take random points P, coordinates are x1, y1, and another point Q, the coordinates are x2 and y2. Now, in order to get to the gradient formula, what we'll do, we'll draw a dotted line from Q parallel to the y-axis and another dotted line starting from P but parallel to the x-axis, which means that will create us a right angle triangle. So this QR is parallel to the y-axis and PR is parallel to the x-axis. And remember the step 3 in finding the gradient, we have to find the tan of this angle, tan theta. So how do we do that? Now observe, if this angle is theta, so this particular angle will also be theta, as I have shown here. Now, since we are supposed to find the tan of this angle, so consider this right angle triangle PQR. Tan theta, remember, is opposite upon base. So we will write tan theta will be equal to opposite is QR and the base is PR. So tan theta is QR upon PR. So what is the length QR? For that, we will be using the coordinates. Q has a y coordinate of y2 and P has a y coordinate of y1. So if we subtract them, that will give us the length of QR. So QR is y2 minus y1. Similarly, PR, the horizontal distance, will be x2 minus x1. So if we put these expressions in the formula, we are going to get tan theta is y2 minus y1 divided by x2 minus x1. And this is that gradient formula which we are aware of, which is also called the rise upon run formula. And this is how we figure out the gradient either using the graphical way or directly using the gradient formula. Next off, we are going to understand how to use the gradient and area under the graph in questions. For that, we need to go back to the basic definition of gradient. Let's start with gradient first. So we have a graph, x and y axis, and we have a straight line. Now remember, gradient is rise upon run. So according to the formula, this is a ratio of how much y is changing with respect to x. What does that mean? Gradient is delta y upon delta x. So from this point onwards, please remember whenever in a question we have to figure out the gradient, that actually means delta y upon delta x, but the axes are important. Here the horizontal axis is x and the vertical axis is y. But on the other hand, what is area under the graph? So we have the same straight line. To find the area under the graph, what we need to do, we have to draw a dotted line starting from the rightmost end and which is perpendicular to the x-axis. So like this. And then area under the graph means the area which is between the line, this dotted line, and the x-axis and the y-axis. So basically, this entire region in the middle. This is called the area under the graph. But the key point to note here is gradient is the division y upon x. In area under the graph, we will do multiplication. So area under the graph will be the product of the axis. So y into x. Let us try to use these concepts in an example. So consider we have a graph. Axes are important. Horizontal axis here is velocity and the vertical axis is p. P is momentum, which is the product of mass and velocity. So if in the question they give us a graph like this, there are only two approaches we can use while solving graph-based questions in physics. Either we do gradient or area under the graph. Let's start with gradient. Gradient is nothing but delta y upon delta x. So y upon x. In this case, the y-axis is momentum and the x-axis is velocity. So we will write the gradient as p upon v. And according to the formula for momentum, which is nothing but m into v, so let's replace p as mv. So you will see that v will get cancelled out and eventually the gradient will come out as just m. Hence, the gradient of a momentum velocity graph gives us mass of the object. But had we tried to do area under the graph, that would mean multiplication. So that would mean p multiplied by v. Now, there is no such parameter which is P into V. That's why area under the graph is not that useful. But let's say even if you find the area under the graph, that is going to give us the value of P multiplied by V. But if we do P divided by V, that gives us the mass of the object. Hence, the gradient is useful here. Now let us take an example where area under the graph makes sense. So let's say this is the graph, horizontal axis is t is the time, and the vertical axis is force. And let's say if the graph looks like this, if we try to use the gradient remember is y upon x. Here the y-axis is force, so the gradient will be force divided by time. Now in physics, force divided by time is no such parameter. So gradient is not that useful. But if we do area under the graph is y into x. So in this case, it will be force multiplied by time. And that is an important parameter in physics. So let me explain. Starting with, we have to find the area under the graph. Remember the steps. Starting from the extreme end, we draw a dotted line which is perpendicular to the x-axis. And then we shade the entire region which we require. According to the concept, area under the graph is the product of the x-axis and the y-axis. So in this case, the area under the graph will be product of force and time. And there is a concept called impulse momentum theorem, which will be explained later in chapter 2. But the formula goes like this. Force and time, when multiplied, gives us the change in momentum. Hence, in this case, area under this graph will give us change in the momentum. In the entire class 11th and class 12th, whenever you see a graph-based questions, there are only two approaches we can do. Either we use gradient or we use area under the graph. But which one to use in which question? The trick is simple. Gradient is the division of y and x, and the area under the graph will give you the product of what is on the x-axis and the y-axis. And this concept we are going to use in almost every single chapter of class 11th and class 12th physics.